look at the example shown here. The objects can be classified as either green or red. The task is to classify new cases as they arrive. Using naive Bayes, you can classify the class labels based on the current objects. Since there are twice as many green objects as red, it is reasonable to believe that a new case, which has not been observed yet, has the same ratio. To maximize your knowledge on the naive Bayes algorithm, you will need a basic knowledge of the Bayes theorem. In the Bayesian analysis, this belief is known as prior probability. Prior probabilities are based on previous experience, which in this case is the percentage of green and red objects. It is often used to predict outcomes before they actually happen. As there is a total of 60 objects, 40 of which are green and 20 are red, prior probabilities for class membership are as shown here. Prior probability for green is 40 by 60, and the prior probability of red is 20 by 60, or the number of the red objects by the total number of objects. The more green or red objects there are in the vicinity of X, the more likely that the new cases will belong to that particular color. To measure the likelihood, we can draw a circle around X, which encompasses a number of points irrespective of their class labels. Then, the number of points in the circle that belong to each class label can be calculated. From this illustration, it is clear that the likelihood of X given green is smaller than the likelihood of X given red, as the circle encompasses one green object and 3 red ones. Thus, the second set of equations. Although the prior probabilities indicate that X may belong to green, given that there are twice as many green compared to red, the likelihood indicates otherwise. The class membership of X is red, given that there are more red objects in the vicinity of X than green. In the Bayesian analysis, the final classification is produced by combining both sources of information, which is the prior and the likelihood, to form a posterior probability by using the so-called Bayes rule. Finally, we classify